Hello and welcome to my video on templates. As I mentioned in my previous video on namespaces in the standard template library, templates are a dense enough topic that I think they warrant their own series of exercises, and that's what I've put together specifically for this video. So we're going to dive right into our first exercise, which asks us to write a function called trend direction that takes a vector of values and determines if the elements are increasing, decreasing, or both/neither. So if they're going up and down, they're obviously doing both, and if they're all the same, then they're not changing at all. We also want to know, is the change linear or non-linear? So if the difference between two elements is the same for any two elements, two adjacent elements, then that's linear. But if two of them are close and then the next two are far apart, then it's a nonlinear difference. Now, the trick is that I want this to work regardless of if it's integers or floats or doubles, and I don't want to have to write, three different functions for this. I just want one function called trend direction, and for that I need a function template. So in my make file, I have our files are going to be called main.cpp, and the executable will be enviro. So let us make main.cpp, and in here, let's copy the description. So the elements of this vector are going to represent environmental measurements over time, so that way we can look at the trends. And in later exercises, we'll expand on this a little bit. But for now, I want to include IOStream, include vector, use the standard namespace, and I want to main. I'm going to make some tests just to make sure I've done this correctly. So we're going to have a few vectors. Let's say I want a vector of integers. That'll be my first set of values. And we'll do 1, 3, 5, 7, 9. This is linear. They're all going up by 2. And it's increasing. So they're all going up. Now, let's also make a vector of floats. So this will be values 2. And how about now we have one that's going down? 5.5, 4.4, 3.3. But also, I'll have it jump to 0. So this way it's a non-linear change at the end. And I also want to have one of doubles, where they're going down, but then suddenly they spike up. So here it is neither, well, I guess it's both increasing and decreasing. They're going down, and then they go up, and then they go down again. And then finally, we'll do one of floats again, but this one, let's have them all be the same. Or how about we have them be shorts? So 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Okay, so if I've done this correctly, I should be able to output for values the trend direction, values trends. We'll output the trend direction of values, and then we'll do that for all 4 of these. Values 2, 3, 4, 2, 3, 4. Okay, so now I have my vectors, and now I need a function called trend direction. And it's going to take a vector of values, and it's going to return a string that tells me the trends. Now, there's a catch though, is I can't write int here, and I can't write double here, because those are different types, but I want this to work regardless of what is contained in my vector, which means I need something to substitute in here, and this is where templates come in. So I need to declare that this is a template function, and it is going to have a type named t, and this t substitutes for any other type that's supposed to work for my function. So it should work with any numerical type, which allows me to compare. I can do less than or greater than or subtract, and as long as those operations are supported by whatever t is, then my function should be accessible to any of them. Now, first thing I want to do is find out, well, first, are there enough elements even? If values.size is less than 2, I can just return not enough elements for a trend, because there's only one element. So I can assume there's at least 2 elements. Now what I want to figure out is, okay, are they all the same? If they're all the same, then that's also something else. So let's say int I is 0, while I is less than size of the vector -1, and values at I is equal to values dot at I plus 1. So as long as there are adjacent duplicates, then let's get I to go up. Now, if it's all the same, then I will eventually become values dot size minus 1. That means I've gone through the whole thing. I's been going up constantly. Each pair of elements is identical, and now I've gone through the whole thing and they're all the same. And if that's the case, I can just return all elements are identical. That's pretty simple. Now, otherwise, first of all, it may have gone up. If I is bigger than 0, that means I know for sure this is nonlinear. There were some duplicates and then some that were not duplicates, so clearly a nonlinear trend. So let's set a Boolean value linear. We'll assume that it might be true, and then if we can confirm that it's not, then we will stop. So if I is greater than 0, then clearly linear equals false. Now I want to know, okay, is this increasing, decreasing, or both? Because if we're at this point in the code, I've gotten past the everything's the same, so they're either something's going up or something's going down, or both things are happening. If values.at, I'll copy this again. Yep. If this one, the element that we've got to, is less than the one after it, then theoretically this could be increasing. So let's get a string for trend. Initially we don't know what it's going to be, but if we get to the point where one element is less than the one after it, then the trend that we see is clearly increasing. However, it could also decrease after. So now for I less than values.size minus 1, I plus plus, I want to see, okay, is it still going up as I go through? If at some point the element I'm looking at is bigger than the one after it, then the trend is actually increasing and decreasing. Now, I get to reverse this for the other scenario, which is else. Then the trend is decreasing, and if a value is suddenly smaller than the one after it, then it ends up again doing both. And now my result, oh, and I also want to see, are these differences linear, by the way? So let's take a look at what the difference is. Let me move some variables around a little bit to make this a little nicer. So first I check for enough elements. So now let's get the difference. So note that the difference between these two values is something that I need to figure out. So here I have to be very careful, is because the difference between two values, I don't know necessarily, is that going to be the same type as the element itself? So when I'm comparing the difference between two integers, the difference is an integer, right? But maybe I might have two things where the difference is not an integer, and that's where this might actually not work out. So I don't want to store the difference in a variable. Instead, what I'm going to do is I'm going to look at, is the difference between each two elements the same as the difference of the elements from before that. So what I mean is, if I have three numbers, like say 1, 2, 3, the difference from 1 to 2 is 1. The difference from 2 to 3 is also 1. And that should be consistent for everything. Now, first of all, I need to assume that there's enough differences to look at. So if I is greater than 0, because if there's only two elements, then I clearly don't want to do this. Assuming I is bigger than 0, then if the difference between these, so that's each element, one element minus the one after it, if this difference is not equal to the difference between I minus 1 and I. So there's this difference and this difference. They should be the same if it is linear. If they are not the same, linear is false. And I can actually copy this exactly in my decreasing situation here. Okay, so now I have this to determine if it's increasing or increasing and decreasing. Here to determine if it's linear or not. And here's decreasing or increasing and decreasing. So now that I have all these things, I can put my result together. First of all, I need to see, is it linear? If so, I can say linear, otherwise non-linear. And then I can add with a, or I can just say and plus the trend and return the result. Let's see what this looks like. Make and run. So I think this is what I was expecting. Let's actually print out our values just so we have them. For auto value in values, cout value. I can do it again for values 2, again for values 3, again for values 4. Just so I can see it a little nicer. Oh, I don't want them to be separated by new lines. I want them to be separated by commas. Otherwise, this is going to be really messy to look at. Comma, comma, comma. Then we'll output a new line. Just make this a little easier to read. Here we go. So here we have linear and increasing, sounds good. Here we have non-linear because they're apart by 1.1, but then suddenly apart by 3.3. So it's non-linear, and also they're all decreasing. There's no sudden jumps. For values 3 here, it's non-linear because again the trends are quite different, and it's both increasing and decreasing. And finally, for all 3's, all the elements are identical. So what I now have is a template function. Regardless of whether I have ints or floats or shorts or whatever I want, my trend direction function I only have to write once, and it will compute all of the trends that I am interested in. So that's part 1 of this, and let's move on to part 2. Okay, for the second part here, I want to create a template class as opposed to a template function. And the class is going to have a type that we allocate t, which will represent either an int or a float or so on. And this reading is going to have the value itself as well as units and a name, just so it has some extra features included in it. I'm going to put multiple objects of this class in a vector and pass it to the function we wrote in our first exercise. So to get started, I'm going to first of all open a new folder, and let's make this reading class. So reading.cpp. Include iostream using the standard namespace. And here I have the class called reading. And reading is going to be a template class, which means it needs to have a type. It'll have a name. Oh, I should put the description in here. It will have a value, and value is not an int or a float, it's t, whatever that happens to be. And then we have a unit. Now I need a constructor for reading, which means it needs a name, it needs a t, whatever that is for the value, and it needs the units. And I can assign them to the respective variables. The value will be v, the unit will be u. And that's, I think, good enough for now, just to get started. Let's grab everything we had from before. Although I also want to make sure reading.cpp is included here as well. And in main, let's include reading, just so it's there, and double check that this builds. We're okay, so all is okay so far. Now, I want to be able to create readings, put them into a vector, and send them to that first function. So down below in our main, we got our vectors. So let's make a new vector. This one will be a reading, and let's make it a reading of ints, just so we have something. Value's 5. Now I need to populate this vector. Let's give it maybe 4 values. And we're going to need to build a int reading. Let's say R. And we'll call it reading number I. The value we'll give it is, let's say, I times 100, just so it has something. And this will be an int, because we have an int here. And then for the type, let's just stick with ppm. We won't play too much with the type for this exercise, but you may want to think about what happens if the types don't quite match. And then for each of these, we will put them into values 5. Okay, and then for each value in values 5, print it out and get the trend direction. Now, a whole bunch of stuff is not going to work. In fact, I'm not even sure it'll be able to load all the errors that are here. Let's find out. Make run. Whoa, that's a lot of errors. Yep, I can't load them all. There's so many. But they are all basically the same error. And when you see so much stuff like this, you want to look for the colors. And in particular, red is something to look out for. No match for operator lesser than. And this is where the overloaded operators come back in, which is that I can't write values.at I less than values.at I plus 1 because the computer doesn't know how to compare readings. I need to overload some functions so that I can compare readings, and I need all of the operators we had from before. This means I need the Boolean operator less than given a reading. We'll call it other. And this will return this value less than the other's value. And I need the same thing for all of the operations that we're using. And so we have greater than, not equal, equal to, and we also have minus. So this should fix some of our problems, but not all of them. So now we actually can at least scroll to the top, and it says we just have one problem left, which is no match for operator arrows. So I gotta be able to print it too. Now this I need to declare as a friend function because I want cout to be on the left side of my reading. So let's make a friend function. Friend sorry, this will return an OStream reference operator arrows given an OStream OS and the reading R. And here OS can receive the name. So this will be, if I want to print it out, it's reading colon value space unit. So that should print out a reading, and it can return OS. And let's give that a try. Clear, run. Okay, so linear and increasing, that looks right. It's 0, 100, 200, 300. Ooh, it looks like it's not printing quite right, because it does reading, eating, adding, ding. Yeah, that's not quite correct. Probably because their names are not being assigned correctly. Where do I assign the names? What a very strange error, by the way. Oh, it's not putting in the number either, actually. So I think that's what's happening here, is that when it's doing reading plus I, it's because it's trying to move the pointer from R to E to A to D, moving up by 1 each time. That's not what I want to do. I want to concatenate strings. So how about we convert that to a string, shall we? There we go, reading 0, 1, 2, 3. That's what I wanted. And we have everything working as desired. So the nice thing about this is that I didn't really have to tinker with much in the main other than adding the new vector. My function I wrote before, my trend direction, still does exactly as it does. I didn't have to touch the code whatsoever. All I had to do is create this new class, indicate what it means to be less than, greater than, so on. And here I am making a bit of an assumption that the units are the same. If the units aren't the same, maybe this whole thing falls apart. But for now, if I have all units of the same, or all readings of the same unit, I can do a proper trend prediction, which is what I wanted. Okay, so now we can move on to part 3. So part number 3, add a full template specialization of reading for string that accepts input such as 415 ppm and parses it into a numeric value and unit using string stream. Use a vector of these readings to send to your trend direction. Okay, so once again, just going to grab everything, put it into a new folder, paste. Okay, and we have to make a template specialization. So what that means is that right now, reading has type T for its value, but there may be a situation where I don't want to make a reading int, I want to make a reading string. And to do that, I'm going to need to declare this again, except I'm going to explicitly say what it means to be a template for a string. So when I create a reading, if I indicate it's a string, it won't use type T because that's going to work differently than the one we have here. Here what we'll do is we'll assume value is actually going to be an int. And when we construct our string version of the reading class, instead we will actually take a single string as the actually, we'll take let's take 2 strings. We'll take one for the name, and then one for the data, is what we'll call it. We'll assign the name to be n, and then what we'll do instead is we will use what's called a string stream to parse the other 2 points. Now, I think I need to include a stream for this, if I'm not mistaken. And I am going to... Oh, no, I'm modifying the wrong program. I hate when I do that. Let's go back to before I pasted this. Yes. Okay. Gotta remember to close everything up before I do this. Okay. Back to where we were. Included string stream. Let's create an input string stream. Input string stream. is given our data. Now you can think about this as a file, sort of like when we read in a file, we can put the data from that file into variables. We'll do the same thing here. From our input string, we're going to put it into the value and then put it into the unit. And the really cool thing about this is that now when I create a reading, I can just give it a name and then 415 ppm, and it will do, again, what I want. So in my main, let's make a 6th set of values. It's got values 5. Let's do one of strings of value 6. And now we'll still do reading number, the number, but instead of doing something ppm, we're going to need to make a string for this. So string data equals, how about we do toString I times 45. How about I times I? How about we make it cubed? But let's start with I plus 10. Or no, I times 10 times itself. So I times 10. I times 10. Just so we get something that's non-linear. So this is going to be our first string, and then plus space ppm. So here's our data. It might look like 0 ppm, then what's that, 100 times 100, so 10,000 ppm, and then 20 times, is it 1,000? So I times 10, oh no, sorry, it's going to be 10 times 10. So it's going to be 100 ppm, then 20, so 400 ppm, 900, I suppose. I guess we'll see if I did it wrong. And then here we'll pass the data. And then again, down below, let's output value 6. Value 6, value 6, value 6. Okay, let's launch. Make run. Yeah, 100, 400, 900. So yeah, 0, 1, 4, 900. Now, this isn't quite right, because this says linear and increasing, but this is definitely not increasing linearly because the difference between them is nonlinear. So I have a mistake somewhere which I need to correct. When I determine if it is linear or not, now let's see here. So apparently it did not run this. If values, what did I mess up along the way here? So for a string, the subtraction is the difference between this one and the other one. That's correct. If the difference I play the size about 1 I is greater than 0, then if the values at I minus this is not equal the previous one minus one before that, then the is false. That should work. I assume I have the same thing over here. So to sanity check this, how about we put in a print statement? And let's get rid of all the ones other than the one we care about right now. So let's comment all this out. Comment out. I guess the rest don't really matter, it's not printing anything. And let's see what happens here. Values I equals values I equals I plus 1. I want to see why this is not working. Make run. I should have printed something, yeah? We compiled it. Oh, because it's not decreasing, it's increasing. That's why. Let's try that again. Increasing. Okay. So 100 and then 300 and then 500. So clearly those differences are not identical. I is greater than 0. Check. Ooh, I know why. I made a small mistake here, which is that I put the wrong types for some of these. The result of subtracting should be a t for my template, and for a string should be an int. And the reason it says that it's equal and linear is because it was getting Boolean values, which were true all the time, which is not helpful. So this should now fix that. Kind of things that you only know if you know how to debug. nonlinear and increasing, which is what I wanted. Okay, now we can move on to, didn't miss a step, right? We're good for steps. Made my template class, made my template specialization, sent the vector, and now we're good for final exercise. Last one, exercise 4, define a region class that stores a region's name and country. Create a template class report that contains a region and a vector of readings. Implement functions to add readings, print the report, and display the trend direction. So here we're just really solidifying our understanding of the formatting for templates. Starting with closing everything, so don't make the same mistake as last time. I'm copying everything over. Copy this, new folder, paste. And I'm going to need to have a report that contains regions, and regions are really just name and country, it looks like. There's not anything interesting about it otherwise, so we'll just make a really quick region class. In fact, I might not even need to make a whole file for this. Let's actually just make this report, and then we can declare region inside of report. Now we do need to include reading, which means we may need to put a pragma once in here. Okay. Probably I should split this into a header and the CPP file, but I might be safe just doing pragma once for the time being. Okay. For my report, I first need a region. And a region is simply going to have a name and a country. And probably I want a public method. So what I'm going to be doing with this, I'm going to be printing a report. Trend direction doesn't require the region. Adding readings also doesn't require the region. So just printing a report means I need a, let's call it toString, given a, I guess nothing. And here I can return region name plus name plus, let's just space this out probably. Slash n country colon plus country. Yep, that's the string. Okay, so I got my region, and now I need my report. Report is going to be a template class. Type name T, because this might have a collection of int reports or string reports or so on. Keep in mind I cannot mix and match the reports here. They're all going to have to follow the same type. So I need my region R, or I guess I could call it region for a proper name, and also a vector of readings of type T, which are my readings. And then my report, I think at most I want to give this a region as a constructor. Region R. Alternatively, I can just give it nothing. And I should be able to do void set region, given a region equals R. I can probably pass this by reference. I think this should be okay to do. And void add reading, given a reading of type T, R, and this will be readings.pushback R. So now I can set the region, I can add readings to it, and I want to be able to, let's see, add readings, check. Print the report, display the trend direction. Now, we're having a bit of a circle here where I have the function trend direction shows up in my main, but my main needs to include report, which needs to include trend direction, which means I should probably move trend direction. So since trend direction is its own thing really, I probably should just make a file for it. Let's call it utils.cpp. And inside, I'm going to put this. Shorten my main code a bit. Here is utils. Pragma once. You include IOStream and use the standard namespace. Since I'm doing that, I don't think I need IOStream anymore, or standard namespace, because it's coming from utils, if I'm not mistaken. My makefile should include all these things. Report utils. Now, right now my report and region don't do anything, but that's okay. I should still be able to run this, or I've made a mistake. Warning, pragma once in the main file, that's okay. Vector does not name a type, and that's because report is missing my vector. What's the problem in here? I forgot to include vector in trend direction. Yes, that makes sense. Okay, so we're all fine for now. Okay. Now, in my let's see here. I did this because I need my report to call trend direction, which means I need to include utils.cpp. Since I'm including utils.cpp, and I can do this, yes? You're not too unhappy about it? Okay. Now that I have access to trend direction, I can say void trend. Or actually, how about I do, to display the trend direction, how about I print the report? So we'll do print, and our print function will say report for, and then here I can do toString of the region. Report for this region, and then for the report I can print out each reading. And so to print out the readings, the code that I used was back in my main, which was to do, well, I guess I can just directly output them, right? So for each reading in my readings, cout r in a new line. So this will print them all out. And then finally, for the trend direction, what was the thing I did there? So I just called trend direction because it gave me a string that I could print out. And then I can do trend direction of readings. Okay, are we happy with the code? No compiler errors, it's a good sign. Let's try to make a report. So I need to get a region, I need to create a report, and I need to put some readings in it. So we can toss most of this stuff out. Let's just leave ourselves with the last set of strings that we made. So my values. I don't want to do this anymore. Instead, what I want to do is I want to create a region R, and what's the constructor for that? No constructor right now, which means I need one. Region name country. So let's construct a region. Let's say Greater Toronto Area, Canada. And then I can make a report. Should probably call my region region. Let's make a report it needs a region as for its constructor, and then for each of my readings, let's add them using add reading. So report dot add reading of my values I. So now I've added them all to my report, and then my report I can call print, and we'll see if it prints out my report. Ooh, got a mistake here. Class template deduction failed. No matching function for call to report given a region reference. Could not deduce type. Oh yes, because my report didn't say what kind of report it was. This needs to be a string report. Or actually no, this is a string report? Oops, not here. In here, I have to say what kind of report it is. Well, it's a type T is the kind of reading. So if the readings are strings, that means this should be a string kind of report. I think that makes sense. All right, so report for GTA. I got my country. I got each of the readings. Trend direction is there. I should add one last little new line character to clean this up, make it look just a tiny bit nicer. Oops. See what, oops, I put it in the wrong spot. There we go. Hey, did that not build? Trend direction, output, make clean, clear, make run. Got some warnings, but these warnings are, I think, just because I'm being a little sloppy here with regards to my inclusions. Note that I use all CPP files, which is probably a bad idea. I really should have separated this into headers and CPP files, but I'll perhaps leave that as an exercise to take home. So we have our functioning code, though, using our template class. And in fact, we have two template classes, one that uses another template class. Which is a great chance to sort of see how these things interact with one another. I encourage you to take the code from here under the videos folder, play around with it, see what kinds of things you can do, and thanks for watching. I'll see you in the next video.